Welcome to the Deep Dive. We're the place you come to get the ultimate shortcut on, well, some pretty complex stuff. And today, we are wrestling with a document that's, well, it's something else. It presents itself as a unified theory of everything.
Right.
But the authors apparently started it as a, quote, shitpost.
Yeah, that's the framing, isn't it? It definitely grabs your attention.
It does. So we're diving deep into the COSI stack, that's conformal OSI model. It lays out this whole 7-layer architecture for physical law, and it claims to unify, get this, FTL travel, entropy, quantum mechanics, and cosmology.
It's ambitious, to say the least.
So our mission today is really to unpack this structure and try to figure out why the authors are insisting this satirical thing ended up being a metaphysical rendering protocol.
That's their phrase. Well, it's immediately fascinating, I think. It's just the level of internal consistency they seem to aim for. And the tone, it's this aggressive confidence. It doesn't just propose a new model. It actively throws shade on established physics. They say things like, relativity forgot entropy, or quantum mechanics forgot version control.
Version control.
And maybe the most cutting one, thermodynamics is stateless.
Wow, okay. That is certainly a bold way to kick off a physics paper.
Absolutely.
But here's the thing that makes us need to look closer, right?
Yeah.
It's not just philosophical potshots. They actually provide functional equations.
Exactly. And they claim testable results. That's the crucial part.
Okay, so what kind of results are we talking about?
Well, they claim this stack successfully computes Mercury's perihelion to 43 arcseconds, which is, a classic test for general relativity.
Right, that's a big one.
And maybe even more impressive, they claim to derive the value of the fine structure constant, alpha, directly from the model's logic.
Whoa, okay, so deriving a fundamental constant.
Precisely. So it's not just like a joke with some math sprinkled in.
Yeah.
It feels more like a mathematical model wrapped up in this really specific, provocative joke.
Yeah.
And the challenge, as they kind of frame it themselves, is figuring out if this is just pure, super elaborate satire, or if it actually is a memetic model that accidentally grew a physics engine. Their words again.
Okay, all right, let's try and unpack this architecture then. If reality is running on a network stack, we need to understand the layers. How does this COSI stack actually work? 7 layers, routing physical processes instead of, like, IP packets.
Yeah, basically. And like any stack, you really need to start at the bottom to understand the foundation. Layers 1 and 2, they sort of define the absolute hard limits, the OS and firmware of reality itself.
Okay, layer 1.
Layer 1 is the quantum substrate layer. You can think of it as the universe's minimum system requirements.
Minimum specs for reality.
Kind of, yeah. They define it as a Planck resolution compute mesh, and it explicitly uses Planck units, the Planck length, lemma time, Planck time, TP, to set these fundamental limits.
Limits on what?
On measurement, on speed. It's like saying the universe's, minimum refresh rate and pixel density are hardwired right there at layer 1.
Okay, so that's the absolute base. The hardware, maybe?
You can think of it that way. And if layer 1 is the hardware, the compute mesh.
Then layer 2 must be the code running directly on it, the basic logic.
Exactly. Layer 2 is the wave function evolution layer. This is where the standard unitary transitions happen. They actually call it Schrödinger logic.
Schrödinger logic, okay.
So this is the smooth, continuous evolution of quantum states before anything forces a resolution, before an observation or interaction. It's the background process, making sure the basic quantum rules are followed.
Right, makes sense. But now, moving up, this is where COSI seems to really diverge, right? Layers 3 and 4 start integrating things. Physics usually keeps separate. Layer 3 is the entropy flow layer. Wait, why does entropy need routing? Isn't it just disorder?
See, that's the critical difference in their model. Standard thermodynamics, it sees entropy more as this emergent statistical thing.
Yeah.
Disorder happens.
Right.
But the COSI stack insists it has to be actively managed. It needs to be routed, like network traffic.
Like data packets.
Sort of. This layer is responsible for routing thermodynamic load, tracking node to charge those conserved quantities. It suggests entropy is like the universe's version of network congestion or maybe heat dissipation in a computer.
Right.
And the universe has to manage that thermal data load efficiently. Otherwise, well, you risk a crash.
So entropy isn't just a consequence, it's a system resource or load that needs active management. That's a big shift.
It is. And then you get layer 4, the geometry protocol layer. This is gravity's turf.
And this is where they start talking about FTL stabilization, right?
Yes, precisely. Layer 4 is gravity's operational domain. It's not just describing space-time curvature passively. It performs an active function. It, quote, injects Ricci curvature to stabilize warp tunnels.
Injects curvature. How?
Well, they give an equation for it.
Right.
The warp curvature acceleration, V-warp, equals c times e to the kappa r. The implication here is that general relativity in the CSI view is sort of incomplete. It describes the geometry, sure, but it lacks the operational protocol needed to maintain stability when you're doing something like FTL.
So it's defining the geometric conditions you need to keep things stable during one of these non-local jumps. It makes gravity less of a passive background and more like an active network service.
Exactly, an active service provider within the stack.
Okay, so layers 1 through 4 set up the base reality, the fundamental forces, the routing of energy and entropy. What about the higher layers, 5, 6, and 7? You said they deal with dynamics.
Right. These top layers handle the really dynamic, almost metaphysical aspects. Observation, causality management, and even transitions between universal cycles.
Let's start with 5, rendering control layer. Sounds like video games.
It kind of does, doesn't it? Think of layer 5 as the resolution governor for reality. Its job is to, quote, trigger resolution collapse at velocity thresholds.
Resolution collapse,
Right.
like the measurement problem in quantum mechanics.
It seems related, yeah. It ties directly back to the observer, or at least the observed system's state relative to Planck limits. If something, maybe you, is moving very quickly, its local reality needs to collapse into a definite resolved state.
Why? To keep things consistent.
That seems to be the idea. They provide a function for it, the rendering collapse trigger, metaphysical collapse, and it's fundamentally tied to a ratio. The effective length of the system, left v, versus the Planck length, lambdap.
Okay, so how does that trigger work?
When that ratio crosses some critical threshold, perhaps related to information density or speed, this system, the stack, has to trigger a state collapse. It's like the OS deciding, okay, you need to render this part of the simulation now to maintain coherence for whatever is interacting with it.
Huh, okay. That naturally sets up layer 6 then, right? The causal routing layer. If layer 5 is collapsing reality based on speed and interaction, layer 6 must be the traffic cop making sure causality doesn't break, especially with FTL involved.
That's exactly its role. This layer manages causality itself. It handles the mapping for warp jumps, the FTL transitions, and importantly, it deals with decoherence budgets.
Budgets. Implying causality is a finite resource you can spend.
And that's what the language suggests, yeah.
Yeah.
A finite budget for how much you can mess with space-time coherence before things unravel. It also defines something called a causal packet loss invariant, CCPL.
Causal packet loss, like dropping packets in networking.
Kind of.
Yeah.
It's essentially framed as a quality of service metric, but for time and causality. It suggests there's a built-in mechanism to protect the causal continuity of events, even when you're doing exotic things like bending space-time. Causality, in this model, is a heavily protected data stream.
Wow, okay. And then the very top, layer 7, cyclic transition layer. This sounds cosmic scale, beyond just our observable universe.
This seems to be the ultimate layer, yeah. Think of it as a universal version control or system reset. It supposedly manages transitions between fundamental cycles of the universe.
Cycles, like a big bounce scenario.
Possibly aligning with concepts like that, yes. Its job is transferring entropy between eons via phase-coherent resets.
Phase-coherent resets.
It suggests a protocol-driven process where the entire universal system resets its thermal data, its entropy load, before the next iteration, the next eon, begins.
That's mind-bending. So, okay, going back to something you mentioned earlier, the document says the observer, you, are just a badly synchronized observer stack. If that's the case, what specific low-level protocols are enforcing this reality we perceive? Are there examples?
Oh yeah, they list several protocols. And they sound hilariously like they were lifted from, like, Cisco or Juniper networking manuals, but applied to physics.
Seriously, give me one.
Okay, so to handle that eon syncing at layer 7, there's the CPL HSP, that's the cyclic Planck loop handshake protocol.
A handshake protocol for universal resets.
Apparently. The necessary digital handshake before the universe reboots, you could say.
Okay, that's amazing. And what about layer 3, routing entropy? If entropy is like thermal packet loss, there must be a protocol for handling that, right?
There is. They call it the ERP, the Entropy Routing Protocol. Its whole job is rerouting thermal packet loss.
So when things go wrong, like a supernova maybe.
Exactly. When a local subsystem like a star collapsing has a catastrophic thermal failure, ERP, trying to manage the overflow, reroute the entropy packets. They also mention a DPE, the decoherence protection envelope.
Protecting what?
Protecting coherence. It contains this decoherence fragility function. dt equals E to the power of minus the absolute gradient of entropy times time t.
Whoa, okay, break that down.
What it basically implies is that the stability, the coherence of reality, is exponentially dependent on how quickly the local entropy flow is changing. If entropy flow is stable, gradient is low, reality is highly coherent. If it's changing rapidly, coherence becomes fragile, exponentially fragile.
Okay, so stable systems are coherent systems. That makes intuitive sense, actually. Right, this brings us to the practical side. How do they even calculate things within this framework? They dismiss SI units, meters, seconds, kilograms. They say they're fine for baking, not for negotiating with the fabric of reality.
Yeah, that's a key part of their argument for internal consistency. They introduced the Planck native metric stack, or PNMS.
Planck native metrics.
Exactly.
Yeah.
By scaling everything directly from the Planck limit, they argue they eliminate arbitrary human scales and make the math work seamlessly from the tiniest possible measurement right up to the grandest cosmological cycle. SI units, to them, are just, historical accidents. Convenient for us, but not fundamental.
Okay, so what are these Planck native units then? What do they replace meters and seconds with?
They detail two main scaled units. For distance, there's the palameter.
Palameter.
It's defined as 10 to the power of 35 times the Planck length, lambda. And that works out to be approximately 1 meter.
So it's basically anchoring our everyday meter scale directly to the Planck scale.
Precisely. It's like a human scale pixel, but defined fundamentally. It connects our perception right back to that absolute limit at layer 1.
Okay, that's distance. What about time? Seconds are out.
For time, we get something much bigger. They introduce the warp tick.
A warp tick. How long is a warp tick?
It's a truly colossal unit of time. It's 10 to the power of 61 times the Planck time, TP.
And what does that work out to in, normal time?
It's defined as approximately 13.8 billion years.
The age of the universe.
One entire universal cycle, according to their model. So if the palameter handles local space, the source notes, rather cheekily, that warp ticks are the units you use when contemplating universal scale events, or, quote, regrets.
Huh. Okay, so it's a fundamental unit of cosmic time, but with that same satirical edge.
Exactly. It perfectly blends the serious math with the provocative framing.
It really sounds like if you actually adopted this perspective, started thinking in palameters and warp ticks, your whole view of reality would have to shift.
Well, they anticipate that. The stack document actually outlines what they call the symptoms of COSI exposure.
Symptoms like side effects.
Kind of. Or maybe failure modes of layer zero thinking, as they also put it. They're basically the existential crises that hit you when you start realizing everything might just be procedural.
Okay, like what? What are the symptoms?
Well, they list things like the dawning realization. Wait, Schrodinger's equation is only layer 2.
Realizing the entire quantum world is just the kernel, not the whole OS.
Exactly, just the base logic layer.
Or
the really humbling one, asking yourself, are we the rendering event?
Oof. Yeah, that hits differently if layer 5 is literally rendering reality based on interaction.
Right. If layer 5 controls that collapse, then our conscious observation isn't some unique metaphysical event. It's just a necessary rendering call triggered by the stack protocol to stabilize the local simulation.
That's deeply unsettling.
And then, of course, the ultimate symptom they list. You find yourself unironically measuring your commute time in plaseconds.
Okay, maybe not quite there yet.
But moving beyond the philosophical side effects, the document really pushes its own validation method. They provide what they call a QSI Rosetta Stone for evaluation.
A Rosetta Stone? For what?
For judging the model itself. And the core message is interesting. Don't just check if it's consistent with our current physics. Check if the model itself is generative.
Generative. Meaning, can it produce the universe it describes? From its own rules?
Precisely. Can it bootstrap reality from its base axioms?
Okay, how do they suggest we actually do that? How do you evaluate at the correct ontological altitude? That's another great phrase.
It is, isn't it? It means you need to ignore whether you find the jokes funny or the tone arrogant and focus entirely on the underlying logic, the source code, so to speak.
Right.
They give 3 main validation points. First, check for symbolic drift.
Symbolic drift.
Yeah, see if the technical terms like Planck scale or entropy are used consistently across all 7 layers and all the protocols. Do they mean the same thing in layer 2 as they do in layer 6?
Okay, internal consistency of terms. Makes sense. What's second?
Second, and this is critical, check if the model can derive itself without importing physics externally.
Can it pull itself up by its own bootstraps, purely from the initial computational idea?
That's the test. Can the whole structure emerge just from the base premise of a layered Planck limited compute system?
And the third check, you said it connects back to the satire.
It does. The final check is, Do the math, units, structure, and joke form a complete set.
Meaning?
Meaning, if the mathematical equations or the definitions of the parameter and warp tick or the way the layers are structured actually contradict the narrative purpose or the satirical element of that layer, then the whole system fails this ontological altitude test. The joke has to align with the math.
Wow. That's a unique validation criteria. The physics has to be consistent with the punchline.
In a way, yes.
So did they try to prove this generative power? Did they run tests?
They claim they did. The document proudly provides an experimental test suite running on, complex math and, as they put it, powered by spite.
Powered by spite. Love it. What did they simulate?
They show the setup for simulating a Starship Mars transfer.
A SpaceX Starship flight.
Yeah, complete with calculations for the transit time, the landing error, all done using these Planck native units, parameters for distance, kilograms for mass. It's presented as a full engineering simulation run entirely within the COSI framework.
Okay, that's a concrete example. Did it work?
Well, they present the calculations, and this leads to what they seem to see as their most compelling evidence for the model being self-sufficient, deriving fundamental constants.
Right. You mentioned deriving alpha earlier.
Exactly. The model doesn't just plug in the fine structure constant, alpha. It claims to derive an alpha-like constant directly from the logic of stack compression.
Stat compression, like data compression.
That's the analogy. The claim is that fundamental constants like alpha fall out of stack compression. They aren't arbitrary numbers put in by hand. They are efficiency artifacts. They emerge from the system's inherent need to compress information and manage data transmission efficiently between the layers.
So constants are just overhead or efficiency metrics of the cosmic network.
That's the provocative idea they're putting forth.
So bringing it all together, the conclusion the COSI document pushes is what? The universe isn't broken or mysterious?
Essentially, yeah. It's not chaotic. It's just running, in their words, an unpatched rendering protocol with deprecated entropy safeguards.
Like buggy software?
Kind of. They believe they haven't written a theory of everything, but rather the missing user manual for the cosmic operating system.
Okay. That is quite the claim from something that started as a joke.
Yeah.
So the ultimate takeaway for you listening to this, the COSI stack presents itself as this incredibly comprehensive, if highly unorthodox theoretical framework. It really pushes the boundaries between philosophy, computation, and physics. And it does it using this language of network protocols to describe reality itself, backed by a pretty rigid mathematical structure. It forces you to ask, can structural humor actually, maybe, reveal some kind of underlying truth?
And I think the stack's heavy focus on decoherence management is particularly powerful. Remember that fragility function, dt, based on the entropy gradient.
Yeah, stability depends on stable entropy flow.
Right, it frames the very stability of reality as this operational challenge, which then raises a really interesting question for us. If the universe is running a protocol, and if entropy is explicitly defined as packet loss, what kind of theoretical debugging tools would we even need? What would it take to perceive reality as a truly coherent, maybe even error-free system?
That's a fascinating question. And maybe a final thought to leave everyone with directly from the implications of this stack. If Layer 5 controls rendering collapse based on interaction, and Layer 7 is managing entropy transfers between entire eons of the universe, could some of the biggest mysteries in cosmology today, things like dark energy or dark matter, could they just be artifacts, maybe glitches in the protocol, things like causal routes buffering between FTL jumps, or maybe local eon stuttering as the system prepares for a reset?
Is cosmology just debugging the universe's firmware?
Something to definitely chew on while you check your own stack synchronization.